Grace and peace to you all, and welcome back to my channel. This is Donald Siame, author of A Hidden Mathematical Genius Within Reviewed. Show that integral from minus 1 to 1 of x to the power 2n over 1 the square root of 1 minus x squared with respect to x is equal to pi 2n minus 1 double factorial over 2n double factorial. Okay, so first thing, we know that the limits for a beta function supposed to be from 0 to 1, and here we have minus 1 to 1, and you can see that this is it's an even function. So that's a matter of multiplying this by 2, then the limits will be from 0 to 1. Okay, so that's the first thing to do. So we are going to have 2, then integral from 0 to 1. So we have x to the power 2n. Then we can bring this to the numerator there. So meaning the power will change. Here the power is positive half. When it is a numerator, then we are going to have minus half. So we have 1 minus x squared to the power minus half, then dx. Okay, then the other thing is that for this to be a beta function, we need to have a single variable here. Okay, this should be a single variable. So we need to let x squared to be a variable. Okay, so we say t is equal to x squared. Then to make x the subject, just a matter of square rooting to both sides. So you get x is equal to t to the power 1 over 2. Then you differentiate. So you say dx is equal to the derivative here. You say this 1 over 2 will come down there, and you subtract this by 1. So we are going to have 1 over 2, then t, then to the power 1 over 2 minus 1, you get minus 1 over 2. Then this is the dt. Okay, so that is what you need to substitute where there is dx. Okay, so the limits will remain unchanged, because if you put a 0 where there is x there, you will get a 0. If you put a 1, you still get a 1. So the limits will maintain. Okay, so we have 2, then integral from 0 to 1. And where there is x, it's t to the power half. Half multiplied by 2, you get 1. So this is just t. Okay, then 1 minus x squared is t, so 1 minus t. Minus t. Okay, this is half multiplied by 2, you get 1, but there is that n there, so it's t to the power n. Okay, then here the power we have minus 1 over 2. Then where there is dx we have 1 over 2, then t to the power minus 1 over 2 dt. Okay, so first thing, we need to divide out the constants. So the constant here is 1 over 2. That 1 over 2 multiplied by 2, you get a 1. So the constants are cancelled. Okay, then here we have t to the power n, and here we have t to the power minus 1 over 2. So that's a matter of adding the powers. So this will be t minus 1 over 2. Okay, so we have integral from 0 to 1, then t to the power n minus 1 over 2. Then we have 1 minus t to the power minus 1 over 2 dt. Okay, so this is in a beta function form. So what you need to do is just to substitute, to equate this to m minus 1 and equate this to n minus 1. So you say m minus 1 is equal to n minus 1 over 2. Then here we have n minus 1 is equal to minus 1 over 2. Okay, so here is just a matter of adding 1 to both sides. So you get m is equal to here plus 1, you get n plus 1 over 2. So it's n plus 1 over 2. And here if you add 1 to both sides, you get n is equal to 1 over 2. Okay, so in short we are saying this is just a beta of n plus 1 over 2 comma 1 over 2. Okay, now we need to show that this is equal to that. So we know that a beta function is related to gamma function. So it's just a matter of multiplying two gamma functions over the sum of the gamma of the sum of these two. Okay, so this is equal to gamma of n plus 1 over 2 multiplied by gamma of 1 over 2 over, then you add these two, so you get gamma of, this will be half plus half is 1, so it's gamma of n plus 1. Okay, so now let us simplify. So we have gamma of 1 plus 1, n plus 1 over 2. This one is related to duplication formula. But here where we have gamma of half, we know that gamma of half is square root of pi. So we have, this is equal to, so this is square root of pi. So we get square root of pi. Then this is gamma of n plus 1 over 2. Okay, over gamma of n plus 1. This is just n gamma of n, or just n factorial. Okay. Okay, so in this case we just put n factorial. Okay, but this one here, gamma of n plus 1 over 2, this is related to duplication formula. And I believe you remember the definition for duplication formula. It goes like this. We have 2 to the power 2n minus 1 gamma of n, then gamma of n plus 1 over 2 is equal to square root of pi, then gamma over 2n. So this is a duplication formula of the gamma function. So now here we have gamma of n plus 1 over 2. So I need to make this the subject. So it's just a matter of dividing 2 to the power 2n minus 1 and gamma of n. Okay, so we are going to have gamma of n plus 1 over 2 is equal to, we have square root of pi, gamma of 2n over 2 to the power 2n minus 1, then gamma of n. So that is what we need to substitute from there. So here we have, this is equal to, we have square root of pi over, this one is just n factorial, so just put n factorial. So we have n factorial, and this multiplied by, so where there is gamma of n plus 1 over 2, we are going to put this. Okay, so we have square root of pi, gamma of 2n over Here we have 2 to the power 2n minus 1 gamma of n. Okay, so what you do, we can write this in terms of factorials. First, square root of pi multiplied by square root of pi, you get just pi. The square roots will cancel out, so you get pi. Okay, then gamma of 2n in factorial, you just subtract a 1, then you get a factorial, so you get 2n minus 1 factorial over, here we have n factorial. Now from here we can make something to have similar to the double factorial. Come up with 2 to the power n here. So if you have 2 to the power n, this should be multiplied by let's say you say 2n minus 1 the power here, so 2n minus 1 minus n, you remain with what? This would be 2n minus n, you get n, so n minus 1, so we're going to have 2 to the power n minus 1. Okay, I wanted to have 2 to the power n and n factorial. These two will give us a double factorial, which is even. Okay, because I've seen from what we need to show, there is a double factorial. Okay, what else do we need? We also need to make this as a factorial, so you just subtract a 1, so you get n minus 1 factorial. Okay, so this is equal to, so what you can do from the numerator here, come up with n minus 1 factorial. So if you put where there is n, you put n minus 1, like this. We have pi, and we have 2. Let's say we put n minus 1 here. When you expand this, you get 2n minus 2. Now we're supposed to have a minus 1. So for you to get a minus 1, you can say plus 1. Okay, so 2 in brackets n minus 1 plus 1 is the same as 2n minus 1. Okay, so here we have a factorial. Then over here we have n factorial, then 2 to the power n. This one is the even factorial, which is the double even factorial. Then again here we have 2 to the power n minus 1 and n minus 1 factorial. These two, if you divide inside there on the numerator, you get a double factorial. Okay, so we are going to have this is equal to, we have pi, this is 2 n minus 1 plus 1, you get a double factorial over, so this one you divide it inside there, so you get a double factorial, and n factorial and n factorial, it is 2n, again a double factorial. Now you can simplify here what we have on the numerator, just a matter of expansion. You say 2 multiplied by n is 2n, multiplied by 1 is 2, so minus 2 plus 1, you get minus 1. So we are going to have pi, then we have 2n minus 1 double factorial over 2n double factorial. So this is how you show it, hence shown. Thank you so much for your time.